Hello dear students, welcome to Pen and Paper Chemistry on YouTube. Now the topic that we are going to take up is not specifically related to chemistry. Here I am taking up the worksheet for class 10 students of the topic Human Eye and Colourful World. You must be wondering why this worksheet, because I have observed a lot of students struggling to get their head around as to how to prepare for the exams, especially the class 10s. So I have prepared these worksheets that I will share. These are completely based on the NCERT textbook, and I would request you to kind of keep your textbooks open with you when you attempt these worksheets. And once you answer these questions, you will find yourself very, very comfortable. But the most important thing is the pen and the paper in your hand. You cannot get a firm grasp of this topic unless you write what you are, yes, understanding as well as learning. So this is the first one. Please feel free to share the worksheet with your friends, classmates, or any students whom you know would feel benefited from this. Thank you so much for sharing. Human eye and colourful world. Question 1. Draw a well-labeled diagram of the human eye and give the functions of the following parts. Now, cornea, retina, lens, pupil, iris, optic nerve, ciliary muscles. If you notice, this beautiful diagram has actually been sponsored by a student of mine. She has made it, and I have taken the liberty of sharing, of course with permission, on the channel. Second question. What is the nature of image formed in the human eye, and how are we able to see the objects around us? Third, what do you understand by the term power of accommodation? What changes take place in the ciliary muscles and the pupil in order to focus near objects and far objects? So you have to mention over here what happens to the ciliary muscles. Do they contract or relax? And what happens to the pupil? Does it become smaller or does it become bigger? Just one-liners, but make sure that you write your answer crisp and to the point. Question 4. The least distance of distinct vision for a normal eye is 25 centimeter. That means the minimum distance up to which a normal eye can see clearly. That's what it means. So the question is, what do you understand by this statement? Now, although we all know the answer, I would encourage you to see the textbook language, because I have observed that the key terms, many a times the students write the answer, but if the key words in your answer are missing, then despite the fact that you would have understood the topic, you may not be able to score marks. And yes, that is the state of affairs. You need to, we are all working for marks only, right? For the present. B part. What will happen and why if an object is brought closer than this distance, than the least distance of distinct vision? So what do you observe if you bring your notebook too close to your eyes? What is its value for a myopic eye and a hypermetropic eye? You know the trick? How do I remember myopia and hypermetropia? Myopia is a short word, so it stands for short-sightedness. Hypermetropia is a long word, so I consider it as standing for a long-sightedness. Long-sightedness, to be able to see far. It doesn't mean that you are not able to see far. Long-sightedness. Sighted means I am a long-sighted person. That means I can see things in the future, much ahead of their time. So that is hypermetropia. hypermetropia. We can see far objects but may not be able to see near objects clearly. Myopic short-sightedness. We are able to see near, we are not able to see far. Does that help? Oh yes, good. Fifth question. How far can a person with normal vision see? Second part of the same question. If a person is not able to clearly view objects up to that distance, what defect would it be called? Third, as an optician, so supposing you are an optician, what kind of lens would you recommend to the person to correct the defect of his or her eye? Would the power of such a lens be positive or negative? Think. Convex lens, concave lens. Where is the power? Where is the focus positive and where is the focal length negative? And that will give you the answer, right? Because what is power of a lens? Yes, power of a lens is the reciprocal of focal length in meters. And what is the unit of power? Called as diopter, right? Denoted by capital D. Draw a ray diagram to support your answer to the question in C above. So when you, as an optician, you are recommending a lens, what will be the ray diagram? What could be the possible causes of this defect? So what happens to the eyeball? What happens? Yes, you have to mention that. What happens to the lens? What happens to the ciliary muscles? Which part gets affected when we get these defects of the eye? Sixth, a student forgets to wear his spectacles and prefers to sit in the front row of the class. That means the child can see the board from near but not from far. Tell me, is he short-sighted or is he long-sighted? Can he see from near or can he see from far? Absolutely right. That's short-sighted, right? What defect of the eye is he suffering from? So short-sighted means short word. Which is the short word? Correct. It's myopia. What are the possible causes of this defect? Again, talk about the size of the eyeball, the changes. So the lens, does it easily bulge or not bulge? Let's see if you can answer this question. And better for you is to write your answer in points, because when you answer your question in points, it's easy to remember. So jot it down in points. It will be good. Next, would the power of the lens used by him be positive or negative? Explain your answer with the help of a ray diagram. Again, the same thing. Similar question. Previously, I had asked you about long-sighted. Now we are talking to you about short-sighted. Aged people prefer to keep the book away from them in order to be able to read without difficulty. What is this defect called and what is its cause? Now, if you notice over here, I have used the term aged people, old, people who are growing old. Think about it. When does a person require the use of bifocal lens? So, for example, I wear spectacles which are bifocal, which will help me to see near as well as far. So, they have power which is positive and negative. Okay, let me see if you can answer this question. With respect to a prism, when a monochromatic light ray is incident on one face of the prism, define the following terms and mark them on a neat and labeled diagram. So what I've done is I've actually done part of the work for you. This is how you have to draw. This is a hint. So go ahead. You may use the same diagram or you may draw a new one. So you have to tell the incident ray, which one is the incident ray. So probably you can say AB, AC, DE, whatever. Just mark it here. Incident ray, refracted ray, angle of prism, angle of deviation, emergent ray, angle of emergence, angle of incidence and angle of refraction. Next question. Dispersion is the phenomenon of the splitting of white light into its component colors, right? So the rainbow, yes. explain the reason for this phenomena. So when you draw the diagram, probably it is best to draw the diagram and to show the splitting up of the white light into its component colors on the screen. What is the spectrum that you get? The question is, what is the reason for this? Next, with the help of two prisms, Newton was able to prove that sunlight is made up of 7 colors. Explain Newton's experiment with the help of a well-labeled diagram. It is very much there in your textbook. Have a look at it. It will be really interesting to see how Newton worked towards proving the same thing. He went on to say that. Next, the appearance of the rainbow after a rain shower or through water droplets can be explained with the help of refraction, dispersion and reflection. You see over here, I've given you a big hint at the question. Refraction, dispersion and reflection. By the way, these these questions have been framed in such a way so as to give you the hint. It's not necessary that when you get this question in the examinations, you will get it as a complete question. They would probably just give you, explain the phenomenon of the formation of the rainbow. And this is the rainbow I've tried to show you in the sky, which I captured with my own camera. It's not very clear, but probably it'll make the subject interesting. Explain this phenomena with the help of a ray diagram, remembering to mark the direction of the light rays. Now this part is very, very important, because in my experience as a teacher, I have seen the students will draw the diagram, but they forget this arrow to show the direction in which the ray is traveling. So please make sure that you mark the direction, because after all these efforts, why do you want to lose marks, right? Next, what does the acronym VIBGYOR stand for? Oh, class 6. Since class 6 you've been doing that. I'm sure you'll be able to answer. In the visible spectrum, identify the color of light which bends the least, the color with highest frequency, color with longest wavelength, the color with maximum deviation. Go ahead. One word answers. Next. Refraction is the bending of the rays of light when traveling from one medium to another. This phenomena can be used to explain a number of observations in our day-to-day life. For example, when an object is observed through hot air above fire or radiator, the object appears to be flickering. You must have seen bonfire. So when you see a person across the bonfire, you'll see those flames. They are flickering. They are rising like this. You observe that kind of movement. So what explains that movement? The stars appear to twinkle in the night. Now this painting has been sponsored by a student of mine, again with permission, of course. Use your knowledge of the phenomena of refraction to explain your observations in A and B above. So try and draw a ray diagram to show this. An interesting fact: stars and planets can be distinguished by the fact that stars twinkle while planets do not. What do you think could be the reason for this observation? Explain. By the way, this is question number 15. Sunset. I realized. Sorry. This was part of the same question because they are dealing with the same concept. Question number 15. Sunset or sunrise? So here I put a picture of sunrise which I happen to capture, sharing it with you. Sunset or sunrise is given by the time at which the sun crosses the horizon. If you match the sunset and sunrise time scientifically with your practical observations, you see in the newspaper they'll tell you, okay, today sunrise is at this time and sunset is at this time. But if you go to the beach or somewhere where you can see the sunset or the sunrise, you will see that there's a difference of around 2 minutes from the scientific timings to what you observe. You will be able to see the sun 2 minutes before its actual rise and 2 minutes after it has actually gone down the horizon. A refraction can be used to explain this observation with the help of a diagram indicating the actual and apparent position of the sun. Explain this observation. I think the points before will help you to know which diagram you have to draw. Also notice the flattening of the disk. Even this phenomena can be explained by refraction. Yes, you notice at the bottom of the sun, you'll notice a flat disk. What explains this observation? I've tried to make this heading interesting because it gets monotonous otherwise. Very fine particles scatter higher frequency of light, so I've put them in blue. Bigger particles scatter lower frequency of light, so I put it in red. Very big particles scatter light as a whole and it appears white. Oh, by the way, there's a lot of physics involved in it. So we started with biology, human eye, and we ended up doing physics, right? So science is holistic. You connect the different branches, right? Scattering of light by fine particles of colloidal size is called Tyndall effect. I'm sure you must have observed this effect sometime or the other. You can even observe it in your room when the sun rays enter through a small hole in the window of your room. Based on this, you have to do some explanations. Explain the following observations based on the previous slide. First, the color of the clear sky is blue, while at sunset and sunrise it appears orange-red. See, I have that enlarged picture for you. At noontime, the sun appears white, but at sunset and sunrise it appears reddish in color. These pictures I have put so that you are able to remember, you are able to relate to what we actually observe. Yes, these are real pictures. This is a real picture. I've captured it just so that you can connect to what you are studying in paper. Danger signals are red in color. No, I have not put any danger signal. I will only give you a green signal to go on to the next slide. This is an experiment, right, which is mentioned in your textbook. So you take hypo, that is sodium thiosulfate. You add H2SO4 to it and you see yellow particles of colloidal sulfur. Otherwise, if you are not observing it through a light source. But when you observe this beaker from different angles, so when you observe it from above or below, it appears blue. These particles will appear blue. Whereas when you see the refracted light, so light which has got scattered is going here, is going there. The light which passes undeviated, it is focused onto the screen. Now when you observe this light after passing through the beaker, you observe that it is first orange and then red in color. What have we done over here? We've got a light source. The light rays are passed through a convex lens in order to in order to convert the ray of light into a parallel beam. Now that parallel beam is passed through the solution containing colloidal sulfur. Scattered rays, yes, these are the refracted rays. Now what will happen? You will see that these rays are traveling through a longer distance in the beaker. Second set, we've got a convex lens again in order to focus the rays of light at one point on the screen. Are you ready for the questions? Based on the experiment in the previous slide, give the functions of each of the two lenses and of course the solution. I have again put the experiment over here. Explain the difference in the color observed when the same solution is observed from the top and the sides of the beaker and the color when observed on the screen. And the hints lie over here as well. Look at the scattering phenomena. Where do you observe red? Where do you observe blue? And why? Interesting, right? Connect the dots and you will be able to answer these questions. My earnest request to you is to get hold of pen and notebook and answer these questions. And if you feel benefited, please don't forget to put a big smiley face in the comment section. I will share more worksheets like this if you like, so as to help you fare through the exams with confidence. Happy studying to all of you.